Help came in the early 50s from two optical astronomers working at Palomar, Walter Baade and Rudolf Minkowski.
They fastened on these two great observers at Mount Wilson and Palomar, Walter Baade and Rudolf Minkowski. Great men, completely open to suggestions, with very little theoretical interest, but amazed at the beauties of what they could see in the universe and really turned on by the excitement of things radio astronomers saw that were not obvious.
Using the new Palomar telescope, Baade and Minkowski searched for clues. They discovered that the unusual radio waves often came from peculiar-looking galaxies. One such galaxy was NGC 1275. In their pioneering work, Baade and Minkowski paved the way for younger astronomers like Greenstein.
Baade kept chow dogs of unbelievable ferocity, which would devour strangers. Anybody who laughed loud was liable to lose an arm. Minkowski could not ever stop talking in a conversation, and he filled pauses by a rumble, sort of, and so Minkowski was not dreadfully well organized. On the other hand, he had a kind of genius, so that if you asked him, what about that letter? He'd say, and he would look at this 2-foot-high pile of scattered papers, and he would lift up the pile and pull out about an inch of papers, open it, and there was the letter. Or there was a plate, and he would reach for the bloody plate, and he would get a magnifier and hold it up against the light box and say, see, and I'd say, where? And he'd say, see, and he had a thumb about 1.5 inches across. He put his thumb on it. I'd say, don't touch it. Don't touch it. It's all right, just all right.
Optical astronomers and radio astronomers continued to work hand in hand. Powerful radio sources were pegged to galaxies visible through optical telescopes. For Greenstein and his colleagues, the identification of these intense radio sources became almost routine. Then in 1964, the world of astronomy was rocked by a single discovery. Martin Schmidt and Greenstein had been investigating mysterious radio stars they called quasars. One night, Schmidt discovered what he at first thought was impossible. These quasars weren't stars at all, but the most powerful objects ever seen, shining more brightly than most galaxies.
In the paper that Martin Schmidt and I wrote in 1964, we have in several places the remark, this is much more energy than we can account for. And we don't know where it's from. We imagine, in fact, that there is at the heart of this quasar an object we call X, which is doing it. Object X. And that's the end of it, because we have no explanation.
Today, astronomers believe Object X to be a supermassive black hole. Quasars and black holes are hot topics at astronomical meetings. This one brought astronomers from around the world, including Tony Reedhead from California. Also Arno Witzel from Germany.
It was timescales of weeks or so, where he found his 1 or 2% variability in contact, mainly in contact sources.
Papers were presented, views exchanged.
And I'll show you briefly here.
The meeting was judged a success, but as with most meetings, the real progress came later. At a nearby restaurant, Reedhead gathers a group of radio astronomers who all have a deep interest in quasar-like galaxies such as NGC 1275.
1275 is an elliptical galaxy, which is about 70,000 light years across. When we look in the center of this object with for example, the Very Large Array, the VLA, we see that there is a very interesting structure which I'll have to expand here for you. And if I draw out that structure, what we find is that there's a very, very bright core. Now, of course, what we're really interested in is what is the beast in the center that can do this, because it's an enormous luminosity that we're talking about here. It's about 100 billion times the luminosity of the sun. So it's an very high luminosity, and it's coming from a tiny region. Now, the idea is that these are actually fueled by supermassive spinning black holes.
They decide to launch a major investigation of the galaxy.
Which is quite a long way in front, in fact.
The group includes Tiziana Venturi, an astronomer from Italy, and Richard Porcus, working in Germany. John Conway, a postdoctoral fellow at Caltech, has convinced Reedhead that he is ready to lead a major investigation. Now he'll get his chance. The observing team will link radio telescopes in different countries, creating the effect of a single dish thousands of miles across.
So if you want to think of graphically, you start out with Onslow, okay, and then you go a bit further south, and then there's a 100-meter telescope in Bonn, okay, and then a bit further south than that, there's the 32-meter telescope in Noto in Sicily, okay, and then those are the 3 telescopes that we had in Europe. And then you come across the country, and there's a telescope in Haystack, which is Massachusetts, and the VLA, and 2 new telescopes of the VLBA near the VLA at Pie Town and at Kitt Peak, and then the Owens Valley Radio Telescope. The Owens Valley Radio Telescope. The Owens Valley Radio Telescope, right? This is the center of the nerve center.
If the team is successful, they will create an instrument thousands of times more powerful than the 200-inch Palomar telescope. The linkage of radio telescopes is called Very Long Baseline Interferometry, or VLBI. As the Earth turns, the telescopes in Europe will be the first to detect the galaxy. The network of telescopes will span 6,000 miles, forming a system that sees as clearly as a dish almost as large as the Earth.
California, it's about 25 now past 6 on a beautiful high Sierra day. And again, Big 5, 6, 7th, and 8th grade will go skiing today.
Well, I saw the thing coming out of the sky. It had a one long horn and one big eye. I come Mr. Shaking and I said, ooh, it looks like a purple people eater to me.
VLBI is one of the most difficult techniques in astronomy. Normally, the team leader has years of experience. For someone as young as Conway to be the principal investigator, or PI, is unusual.
Any queries or anything goes wrong during the observations, they can get in touch with me. I'm the central person to coordinate things. And that's basically what the PI does. And usually the PI also does most of the analysis afterwards.
Conway has come to the observatory located in Owens Valley, California. It is one day before the observation of NGC 1275 is due to begin.
But NGC 1275, it's one of the closest objects and therefore one of the brightest. Also, you get the highest sort of linear resolution. You can see the most sort of detail in terms of what we can resolve in terms of light years. And so it's very obvious source to study. Because it's very close and you get high resolution, it's also very complicated, which means it's hard to get very reliable images of it. We'd like to get very reliable images because it tells all sorts of things about the motions which are going on inside.